Hey guys, welcome back to another Leetcode video. Today we're going to be looking at Leetcode 1456, maximum number of vowels in a substring of given length. This is a medium difficulty Leetcode problem, and this problem, the description tells us that we're given a string s and an integer k, and we want to return the maximum number of vowel letters in any substring of s with length k. And vowel letters in English are A, E, I, O, U. So we're given a string and we want to return the maximum number of vowel letters in any substring which has the length of k. So here's an example. The substring I contains 3 vowel letters and it also equals the window length, or the substring length, is equal to 3. So we return 3. This is the maximum number of vowels we can have in a substring bound by the k value. So, and we're given a couple more examples, but this problem is, although it's a medium difficulty Leetcode problem, it is relatively simple when it comes to sliding window problems in general. So let's actually get to coding this up. So how can we actually code this up? Well, the first thing we want to do is we kind of want to, instead of every time we have a window, let's say we have a window of size k, and then every time we have a window counting all the vowels, and then adding, and then once we've counted basically all the vowels, and then moving on to the next window, and then counting all the vowels again, and then moving on to the next window, and then counting all the vowels again in our substring, that is just going to be non-linear time complexity, and we want something faster. So what we can do is have a running total and use a hash map, and instead of iterating through our entire substring every time, we can just update that running total and decrement any values which fall outside of our window. So let's actually do that. Let's create a hash map. Let's call it vowels. We'll use a Python dictionary, and we'll set a equal to 0. I'm just going to copy this a couple times. 5 times to be exact. 1, 2, 3. Okay, that's indented incorrectly. We don't want that. Okay, so let's change this to E, I, O, and U. And now all of these values are instantialized at 0. So the next thing we want to do is have a result variable. This result variable is basically going to be equal to the output of how many maximum vowels we can have in a substring of length k. And then we want our left pointer equal to 0. And our right pointer is going to be from our for loop. So we're going to get the range going to be equal to the length of s. Length of s. And we want to say if SR, so if the current character that we are at the right pointer is in the hash map, or sorry, not in the hash map, in vowels, well then vowels SR plus equals 1, we're going to increment this counter that we have. If on the other hand R is greater than or equal to K, well, now we know that we have a window size. So initially we're not going to be having a window size. We want to wait for a minimum window size of k at least to be built, and once we have our window, then we can increment our left pointer to maintain that window. But before we actually increment our left pointer, let's say if the character at the left pointer is also in vowels, well, we're going to be removing it now, aren't we? So we want to instead decrement the count, decrement the running total for this character. And then we can increment the left pointer. And then what we can say, let me just put this up here so it's a bit neater. We can say if R minus L plus 1, so if the window size actually is equal to k, well then we can simply set our result equal to the maximum of the result and the sum of our vowels dictionary, get the values and get the sum of that, and then set that equal to result if it is greater than the current result we already have. And then we can simply return our result. So let's do that. Let's submit our code and check our code actually works. And we get an issue. key error D. S L is what it should be. Okay, and now we pass all test cases for this problem. So quite a simple problem, quite easy to go through, and very intuitive compared to a lot of other sliding window problems. But again, does require a bit of thinking, and the key part really is to have this hash map to store the running totals of all the count of all the vowels in our substring. So since we are using this hash map, time complexity, instead of being non-linear, it's going to be a linear time complexity of big O of n, and the space complexity is simply going to be constant, big O of 1. Technically, it's I guess you could say it's big O of 5, but we can simplify this down to big O of 1. So with that being said, I hope you guys enjoyed this video, and I'll catch you in the next one.